In our early experiment, we mixed the solid baking soda with the liquid vinegar and made the gas carbon dioxide. Now we have a piece of dry ice, which is actually carbon dioxide supercooled into a solid. And you can see the vapor that's being given off. This process going from a solid, not melting or turning into a liquid, but going into a vapor, special word called sublimation. Sublimation. So I'm going to put this piece of very cold dry ice, solid carbon dioxide, into water. Bubble, bubble, toil and trouble. It's creating a gas. And because carbon dioxide has 3 atoms, a carbon and 2 oxygens, it's heavier than the air above it, which is a mixture of oxygen, nitrogen, and carbon dioxide. So as we see this sublimating and going from the solid to the gas, it's forming a certain layer. And we can see that. And we're going to be experimenting. We're going to be doing 2 different activities with this carbon dioxide. And the first one, we did it earlier with a candle. We're going to light a match, light this candle, and it's typically using the oxygen to burn the wax, the flame. And now I'm going to take a cup and carefully dip out some of this carbon dioxide. I'm going to put my hand over it so I don't let it out. And I'm going to very slowly pour it into the cup. It didn't work. That's okay. Let's get a little bit more. All right, I'm going to take a cup full of this heavy carbon dioxide and pour it into the glass. It immediately extinguishes it because the flame needed oxygen to burn. Carbon dioxide is what puts it out. We need oxygen to carry on life processes. We give off the waste gas carbon dioxide, the same process. So our other experiment is going to be making bubbles. And I'm going to take this bubble wand and let's watch when I blow the bubbles. Are they going to float or sink? Okay, they have the air, carbon dioxide, oxygen, and nitrogen, which is all lighter than the carbon dioxide. So what are they doing? They're floating above that layer of carbon dioxide. All right, so we've learned that different gases have different densities. Some are heavier, like carbon dioxide. Some are lighter, like nitrogen and oxygen that we breathe. This experiment is something that you can do with liquids. We have taken table salt, container of table salt, asked you folks to help you. We put a ½ cup of salt in this container, stirred it around. You can see some of the salt that hasn't dissolved below, add a little food coloring. And this one we put a ¼ cup of salt, less salty. And finally, in this last one, it's just water and a little bit of food coloring. So what we're going to do is carefully take some of the very salty water, and with this little plastic pipette, we're going to squish it into the bottom of the test tube. Going to let it, for this first layer, we're just going to squish it in, not being real careful about disturbing the layer. All right, now that was the saltiest, and that would be what? The most dense, because it has the most salt in it. Now for the second one, we're going to take some of the green water, and notice I'm going to put it as close, the pipette, as close to the layer as I can, and carefully squeeze the pipette. Why do you think I'm squeezing it so slowly? If I'd squirt it in there, I'd mix the 2 colors, and that's not what our objective to this experiment is. You're going to take it down to the tip, slowly squeeze it, and you can see the layer, because this is less salty, less dense. One more of this medium salt water. All right, there we have a nice layer. All right, now if you remember, this blue water is just water. It has no salt in it. So I'm going to go right to the edge, move my fingers down a little bit, and carefully squeeze the water, trying not to mix it. You see that blue layer? Let me get a little more water. Objective is not to mix, and there's a little bit of current I can see. All right, so let's tip it up carefully and see our layer of the most dense salt solution the medium, the quarter cup, and the water, and then finally just the water. Have you ever seen a video of somebody swimming in the Great Salt Lake or the Dead Sea? They actually float because they are less dense than the salt water in the Dead Sea or the Great Salt Lake. So this was one I made earlier. They both layered really well. Now if I invert them, what do you think is going to happen? Are they going to come back and stay in that nice layered solution? No. But that was an experiment I wanted to do. It kind of turned into sort of gray water. It didn't, and it won't. It's all mixed together. It won't come back into the nice layers we did before. But that was an experiment that I wanted to try. We've been learning about solids, liquids, and gases during this program. And we have a unique characteristic of one type of substance, and it's called a non-Newtonian substance. Cornstarch, which is a very fine ground material made out of corn, when it's mixed with water, we added a little bit of colorant so you could see it, it forms a unique substance that has some properties that are similar to solids but also liquids. As I mentioned, it's a non-Newtonian substance and it's affected by heat and pressure. Usually something that's solid maintains its shape. Liquids take on the shape of the container they're poured into. Gas just keeps expanding whatever size container it's in. So with this material called oobleck, you can make it at home. Ask your parents to let you mix some cornstarch and a little bit of water, and it makes this solution, and it's called a suspension. The cornstarch never dissolves in the liquid. It's similar to our blood. Blood cells are always in the blood. It's not like a solution or like Kool-Aid. It's like particles, our red blood cells are always suspended in the liquid plasma. So I'm going to get into this and I'm going to show you the characteristic of this oobleck or non-Newtonian substance. I'm going to grab a bunch of it and I'm going to squeeze real hard, put it under pressure, and you can see the shape, but as it relaxes, what does it turn into? It turns into a liquid as it drips through my fingers. This is cool stuff. Let me get a bunch of it. It's kind of stuck to the bottom of the bowl, but as I can squeeze it real hard, put it under pressure, my hand's a little warm. Look at that, it holds a shape, but then because it's a suspension, the little particles, fine, ultra fine particles of cornstarch just go into solution again. So it's called a non-Newtonian substance. It takes on solid characteristics at certain times under pressure, and then when the pressure is released, it turns into a liquid again.